Good morning, viewers. Good morning. And I'm back with the question answers of measurements and experimentation chapter. This is the physics chapter, first physics chapter, which I was discussing before this year ended, before the previous year ended. So I will continue with the question answers. I'll finish this off and then I'll start with the biology chapter, next new chapter of ICSE syllabus class 9. Okay. So hope all of you are fine and you are meditating before sitting for the studies. Okay. And press the like button and share with your friends, and also do subscribe to get the notification of my next videos. Okay, hope you have started a new year with the new boom. Okay, so let me start with first. We'll come to some multiple choice questions. Okay, so first one is the fundamental unit is Newton, Pascal, Hertz, or second. The fundamental unit is second. Okay. Then is which of the following unit is not a fundamental unit? Meter, liter, second, or kilogram? It is liter. Because why it is so? Because meter is the SI unit of length. Okay, so it's a fundamental unit. Second, it's a SI unit of time, SI unit of time. Then kilogram, it's an SI unit of mass. So these three are fundamental units, and which is not the fundamental unit, that is the liter, which is equal to centimeter cube. 1 liter is equal to 1 centimeter cube. Okay, and that is the 1 centimeter. Centimeter is the unit of distance. Okay, so this if this centimeter is 1 centimeter, that is 1 centimeter is the unit of distance. Okay, so that is the fundamental unit. And when you are multiplying 3 times the centimeter, that makes a derived unit. Okay, that is liter. Centimeter cube means multiplying centimeter 3 times. Okay, then that becomes the liter. Okay, and that liter is a derived unit. It's not a fundamental unit. Okay, okay, you have understood, I think so. Next, we come to the unit of time is which one? Light year, parsec, leap year, or angstrom? This leap year is the unit of time. Others, that is light year, parsec, and angstrom, these are all the units of distance. Okay. Higher units of distance, bigger units of distance. 1 angstrom is equal to 0.1 nanometer, 10 to the power minus 10 centimeter, 10 to the power 8 meters, or 10 to the power 4, sorry, 10 to the power minus 8 meters, or 10 to the power 4 microns. The answer is 0.1 nanometer. 1 angstrom is equal to 10 to the power minus 10 meters. And that is equal to 10 to the power minus 8 centimeters, or you can say 10 to the power minus 1 nanometer, or 0.1 nanometers. So first one is the answer. Now Ly is the unit of, it is the light year symbol. So and light year is the unit of what? Length, distance. So B is the answer. The least count of a vernier calipers is what? 1 centimeter, 0.001 centimeter, 0.1 centimeter, 0.01 centimeters. The answer is 0.01 centimeters. Sorry, my throat is still broken. My voice is still broken. Okay. A microscope has its main scale with 20 divisions in 1 centimeter and vernier scale with 25 divisions, the length of which is equal to the length of 24 divisions of the main scale. The least count of microscope is 0.002 centimeter, 0.001 centimeter, 0.02 centimeter, 0.01 centimeter. So vernier scale is equal to 25 divisions, and that is equal to 24 divisions of the main scale. Now, each division will be how much? 24 by 25. That makes 0.96 centimeters. Now, each, the least count of vernier will be Each division, that is the pitch, 0.96 centimeter by number of divisions. How much? How many divisions on the main scale? That is 20. So that will be giving us 0.048 centimeter. Okay. Now, least count of the microscope is equal to least count of the main scale minus least count of the vernier scale. Okay, the least count of the main scale will be 1 by 20, that is 0.050 centimeter. Okay, and now least count of the microscope will then be main scale, we found it as 0.050, and least count of the vernier scale is 0.048, which I deduced it above. Now that makes the least count of microscope is 0.002 centimeter. So the answer will be this one, first one, A. Okay. Now the diameter of a thin wire can be measured by vernier calipers, meter rule, screw gauge, and none of these. It is measured by a screw gauge. Okay. Next, the length of a simple pendulum is made 1/4. Its time period becomes 4 times 1/4, double, or half. When we are making the length of the simple pendulum 1/4. Now, the time period depends on the square root of the length. Okay, it's directly proportional to the square root of the length. Therefore, what happens? If length becomes 1/4, the time period becomes half. Okay. See, if length is 1/4, then time period means time period is equal to square root over L. Okay, and root over L means 1/4. So if we remove this root, then we get half. So time period becomes half. So answer will be the D answer. Next is the time period of a pendulum clock is 1 second, 2 seconds, 1 minute, 12 hours. It's 2 seconds. The length of a seconds pendulum is nearly 1 meters. Okay, not 0.5, not 9.8 meters, not 2 meters. It is 1 meters, nearly 1 meters. Now we come to some questions. Answer the following questions. What is meant by measurement? It is a process of comparison of a given physical quantity with the known standard quantity of the same nature. Okay. So how do we measure? What is meant by measurement? It is the process of comparison of the given physical quantity. What quantity we need to measure, that physical quantity is compared with the standard quantity of the same nature. That means if we are measuring some weight, okay, if we need to weigh something, then we need to compare another standard quantity also of the weight, of the mass of that. I mean, the particular thing the standard quantity should be of the mass. Okay. Now, it is the act of determining size, capacity, and quantity. Okay, what is meant by measurement? Then it is clear that it is the process of comparison of the given physical quantity with the known standard quantity of the same nature. And it is the act of determining, you can say another way, that it is act of determining the size, capacity, or the quantity. Now, what do you understand by the term unit? The term unit is an internationally accepted standard for measurements of quantities. It is a quantity of constant magnitude, which is used to measure the magnitudes of the quantities of the same manner. Okay. It should be internationally accepted standard quantity. Okay, it should be internationally accepted standard for measurement of the quantities. And it should be constant. Okay, constant magnitude. It should have a constant magnitude. That is, it will not change if you change the place. So it should be constant quantity, constant standard, I mean, constant magnitude and internationally accepted. Okay, everywhere it should be accepted. That means if we consider the length, or I mean, the meter to be the length, if we consider that meter to be the unit of length, then this meter should be accepted internationally. Everywhere in every country, it should be accepted the length to be the length unit to be meter. Okay, and the constant this meter should be constant in everywhere. Wherever we go, the length of the substance, the unit of that length should be meters. Okay. Then what are the three requirements for selecting a unit of a physical quantity? For selecting a physical quantity, what are the three requirements? First is the unit should be of convenient size, should not be of exorbitant size. Otherwise, it will not be accepted. I mean, it will differ from place to place. So it should be of convenient size. Okay. It should be possible to define the unit without any ambiguity, without any confusion. It should be easily can be defined. Okay, then the unit should be reproducible. It should be reproducible. It can be reproduced. Now name the three fundamental quantities: length, mass, and time. Then name the three systems of unit and state the various fundamental units in them. The three systems of unit are CGS, MKS, and FPS. Okay, so CGS unit is the fundamental units here. The fundamental units of length is centimeter, of mass is gram, of time is second. And in FPS, the fundamental units of length is foot, pound, mass is pound, and time is second. So FPS, foot, pound, and second. And CGS system, centimeter, grams, and second. Okay, CGS. Then MKS is meter, kilogram, and second. So meter is of length, kilogram is of mass, and second is of time. Easy to remember. Then define a fundamental unit. A fundamental unit is a basic unit that is independent of any other unit. It is the basic unit which is not dependent on any other unit, or which can neither be changed nor can be related to any other quantity. It can neither be changed or cannot be related to any other unit. Okay, it is the basic unit. Okay, and a derived unit is one which depends on the fundamental unit. Okay, now what are the fundamental units in SI system, and name them along with their symbols. Now in SI system, length is meter, so we write it as small m. Mass, kilogram, we write it as kg. Time, second, it's written as small s. Then temperature is Kelvin, we write it as capital K. Luminous intensity, candela, we write it as small cd. Then electric current, it's ampere, and we write it as capital A. Amount of substance, the unit, SI unit is mole, we write it as MOL, small mol. Then angle, radian, we write it as RD, small, in lowercase. Then solid angle, steradian, that is ST, small st, hyphen RD. Okay. Now explain the meaning of a derived unit with the help of one example. I told you derived unit means that it depends, the unit that depends on the fundamental units, or which can be expressed in relation to with the fundamental units. Those units are called derived units. For example, to measure area, we need to measure the length and the breadth in the unit of the length in the unit of length, and then express it area in the unit which is L into L, or length into length. Okay, breadth is also a length. Okay, so, or you can see, we can write length square. So it is a derived unit. Okay, now define standard meter. The standard meter is the length of the path traveled by light in vacuum during a time interval of 1 by 299,792,458 of a second. So much fraction of a second. That is the standard meter. The standard meter is the length of the path of the traveled light in a vacuum. Light that travels in a vacuum, how much it traveled during a time of what type of a second. So time, how much fraction of a second? 1 by 299,792,458. That is the standard meter. That distance is known as the standard meter. Okay, so you need to memorize this number. Okay. Then name 2 units of length which are bigger than a meter. How are they related to the meter? 2 units that are bigger than meter are light year and astronomical units. The units of length, that is light year, is bigger than the meter and is used to measure the astronomical distance. Okay. Then according to the International Astronomical Union, 1 light year is the distance traveled by the light in vacuum in 1 Julian year. Light traveled in vacuum in 1 Julian year, in 1 year, that is. So the unit light year is denoted by Ly. Okay, so 1 Ly is equal to 9.4607 into 10 to the power 15 meters. And the astronomical unit is one of the units of the length bigger than meter, and it is the distance between the Earth and the Sun. And it's denoted by the symbol capital A, capital U. 1 AU is equal to 1.496 into 10 to the power 11 meters. Write the name of the 2 units of length smaller than a meter, express their relationship with the meter. The 2 units of length smaller than a meter are micrometer or micron and nanometer or nm, small nm. Okay, so 1 micron or micrometer is 1 millionth, that is 10 to the power minus 6 part of a meter. 10 to the power minus 6 part of a meter. It is expressed by the symbol micron, and it is also called micrometer. Symbol is micron meter. So this is the micron symbol, mu meter. Okay, so 1 micron, 1 mu is equal to 10 to the power minus 6 meters. Now 1 nanometer is 1 billionth part of the meter, that is 10 to the power minus 9 part of the meter. And it is expressed in the symbol small nm. 1 nm is equal to 10 to the power minus 9 meters. Okay. Now, how is nanometer related to angstrom? 1 angstrom symbol is capital A and a degree sign or small zero sign above A. Okay, and that is 10 to the power minus 10th part of a meter. So it is expressed in the form of symbol I told you, A above 0. Then 1 angstrom is equal to 10 to the power minus 10 meters, or you can say 10 to the power minus 8 centimeters, or you can say 10 to the power minus 1 nanometers. Okay, or you can say, excuse me, 1 nanometer is equal to 10 to the power 10 angstrom. 1 nanometer is equal to 10 angstrom. Okay. Now, name the 3 convenient units used to measure the length ranging from very short to very long values. How are they related to the SI units? Now, the three convenient units to measure the length is, one is nanometer, another is centimeter, another is kilometer. Okay. And the SI unit is what? Meter. So, nanometer is the unit of measuring length in the metric system, which is 1 billionth part of a meter. Okay. One billionth part, that is very small part. Okay, very small. Then 1 nanometer is equal to 10 to the power minus 9 meters related to SI units. Then centimeter, it is the unit for measuring length in the metric system, which is 100th part of a meter. That is 10 to the power minus 2 meters. 1 centimeter is equal to 10 to the power minus 2 meters. Then kilometer, it is a unit for measuring length in the metric system, which is 1000 times a meter. Okay, so 1 kilometer is equal to 10 to the power 3 meters. Okay, name the SI unit of mass and define it. SI unit of mass, we know it is kilogram. Okay, in 1889, definition of kilogram is, in 1889, 1 kilogram was defined as the mass of a cylindrical piece of platinum iridium alloy. Okay, a cylindrical piece of platinum iridium alloy was made, and the mass of that was taken. Okay, and this platinum iridium alloy rod, that is cylindrical piece, was kept at International Bureau of Weights and Measures at Service near Paris. That was weighed. Okay, and that the weight, which were the measurement which came out when we weighed that one, when it was weighed. Okay, so the measurement that came out, that was known as kilogram in 1889. Okay. Then state 2 units of mass which are smaller than a kilogram, and how are they related to kilogram? The 2 units of mass which are related to kilogram are gram and milligram. Excuse me. 1 gram is 1000th part of a kilogram. Okay, so 1 gram is equal to 10 to the power minus 3 kgs, or 1 kg is equal to 1000 grams. Sorry, not kg, 1000 grams it should be. Okay, then 1 milligram is 1 millionth part of a kilogram. So 1 mg will be equal to 10 to the power minus 6 kgs. Okay. Then state 2 units of mass which are bigger than a kilogram, give their relationship with the kilogram. The 2 units of mass that are bigger than a kilogram are quintal and metric ton. Then quintal, how do you define quintal? It is 100 times of kilogram, and 1 quintal is equal to 100 kgs, or 10 to the power 2 kgs. And metric ton is the 1000 times of kilogram, or 1 metric ton is equal to 1000 kgs, or 10 to the power 3 kgs. Now name the SI unit of time and define it. The SI unit of time is second, and the second is what? Second is defined as 1 by 86,400th part of a mean solar day. Okay, so 1 second is equal to 1 by 86,400 into 1 mean solar day. Okay, that is the definition of a second, or you can write it at, it is the time interval of 9192,631,770 vibrations of a radiation corresponding to the transition between 2 hyperfine levels of a ground state of cesium-133 atom. So in the ground state, when cesium-133 atom is bombarded, will vibrate, it will create some radiations that vibrated, and the time interval between the vibrations would be 9192,631,770, and that is the second. That is the definition of second also. So in these figures, you need to memorize by writing it down. Okay, you can't remember just once you see it, you will be able to remember. That is very difficult. So you need to write it down several times, and then you can memorize these numbers. And that should be accurate. If you write this definition in the exams, that should be, this number should be accurate. Okay, otherwise your definition will be, answer will be wrong. Okay. Then name two units of time bigger than a second, and how are they related to a second? The two bigger units of time are hour and century. So hour, 1 hour is the duration of 60 minutes. Okay, so 1 hour we know is equal to 60 minutes. That is equal to 60 into 60 seconds, or you can say 3,600 seconds. And 1 century, that is equal to 100 years. So 100 years means there are certain years which have leap years and the certain years which do not have leap years. So 76 years of in 100 year is they are not leap years, and 24 remaining of the 100 years, those would be having leap years. So 24 into 366, the leap years will have 1 day extra. So 24 into 366 plus 76 years which do not have this one leap years, they will be multiplied into 365. Okay, so that will give the number of days in 1 century. So that gives us 36524 days, and 36524 days will be equal to 3.16 into 10 to the power 9 seconds. Okay, that is, if you multiply this into days, that is 24. Okay, then 24 into how many hours? 24 hours you have converted into. If you multiply it by 24, then 60 into 60, that is 60 minutes, then 60 into 60. So that will give us 3.16 into 10 to the power 9 seconds. Now, what is a leap year? A leap year is the year in which the month of February is of 29 days. Okay, so one leap year contains 366 days. Now, what is a lunar month? A lunar month is a time between two identical synergies. Okay. Syzygies, okay, that is new moons or full moons. 2 new moons or 2 full moons. Its value is 29.59059 days. Okay. And next I'm going to explain the meaning of the term least count of an instrument by taking a suitable example. So the least count of an instrument is the smallest measurement that can be taken with that instrument. Okay. For example, if there are 10 divisions between 0 and 5 mark of a stopwatch, the least count of that stopwatch is 0.5 seconds. Okay, so I think I'll stop here. There are lots of questions to be discussed. Okay, and then after discussing these written questions, we'll be discussing some numericals also. So you need to stay tuned with me. You need to subscribe my channel for getting the updates of the videos which I'll be coming forth with. Okay. And also press the like button, share with your friends so that they can also be benefited from these videos. And don't forget to meditate before sitting for the studies for the day. Okay. So thank you. Thank you for watching and have a good day.